everybody. Hello. How's the weekend? Mine was... How was my weekend? It was pretty good, overall, I'd say. I realized after the last stream, it was Friday. And, well, Friday going into Saturday. And I ended the stream and I didn't say anything about the weekend. Like, have a good weekend or anything. I was like, oh. Oh. But anyway, how was the weekend? Post and comments below. This is the last full week before the dynamic change. I just got out of the shower, by the way. I noticed like my shirt's a little spotty. Just got out of the shower not too long ago, so that's why. Week from tomorrow. Yes, a week from tomorrow. I start my new job. And so things will be changing here in some way. For this, not a lot will change, I don't think. I'm definitely going to be keeping this up. You guys will just be hearing about my job. Yeah, but the timing might be different than what for the majority of time has been. It'll probably be around, I don't know, it might be like 5 p.m. or something when I stream. Who knows? We'll see. We will see. But this is a temporary thing. That's kind of how I'm treating it. I don't know what temporary looks like. I don't know what it means as far as like a week, a month, a couple months. I don't know. But I hope it's not a long time. I really do. I'm going to be working to try and work my way out of this job. I don't know if I've mentioned that before, but that's the goal. So anyway, now that I've yammered for a bit, this is the lesson with like a bunch of exercises. So we'll see how, if this video is like 2 minutes long, we might jump into one of the exercises. But if it's longer, then we'll just do the video, and we'll chew our way through the exercises like we did the last time we had a lesson with like 3. Was it 3 or 2 exercises? 2? 3? I think it was 3 actually. Now that I think about it, so we'll see. We will see. But y'all ever been in a season that's hard and you're like, what's God doing with that trial in your life? Or you're just curious about like the outcome? I'm curious about the outcome. I'm in one. Challenging season. It's been a challenging season for a long time for me. But anyway, enough about me. Okay. Here we go.
Now we're going to talk about API.
We're just doing the video.
Rate limiting and security. The key thing is that the Google API and the Google data is super valuable. And you could build a website that did nothing but sort of like asked the person for something and then showed them that place and be a map searcher. And you added so little value and Google did all the hard work. And so they...
Dude, the way that he said that was kind of interesting to me. Like, you added so little value. It's like, oh, crud. Dang, man. API security and rate limiting. The compute resources to run these APIs are not free. Quote unquote free? The compute resources to run these APIs are not free. Okay. Trying to understand what that would actually... Does that mean the computer that runs? No, that can't be. What else would it be, though? The compute resources to run these APIs? We're talking like bandwidth? Internet bandwidth? The data provided by these APIs is usually valuable. That makes sense. The data providers might limit the number of requests per day, demand an API key, or even charge for usage. Data providers, or so like the data providers who use the APIs might limit. Demand an API key, or even charge for usage. They might change the rules as things progress. Also makes sense.
Protect these somewhat. Sometimes they'll say you can only somewhat, some hard work. And so they protect these somewhat. Sometimes they'll say you can only do 50 of these somewhat. Google did all the hard work. And so they protect these somewhat. Sometimes they'll say you can only do 50 of these a day or 500 a day or whatever. That's called rate limiting. And sometimes they say you've got to log in, you've got to create an account and get a key with us and then present your key. So that means that your account only gets so many. And they keep track of who's using their service and how much they're using it. Google gives you even sort of a dashboard that tells you some of this stuff. It's kind of nice. And so the other thing is sometimes an API is free and then it becomes popular and they decide they're going to put a key on it or a rate limit on it. So you got to kind of play this game with them and the rules kind of change as things progress. So that geocoding.
So this is like an example of usage limits. The Google geocoding API has the following limits in place. 2,500 requests per day. Google Maps API for business customers have higher limits, 100,000 requests per day. These limits are enforced to prevent abuse and or repurposing of the geocoding API and may be changed in the future without notice. Got hair in my mouth. Additionally, we enforce a request rate limit to prevent abuse of the service. Yeah. If you exceed the 24-hour limit or otherwise abuse the service, the geocoding API may stop working for you temporarily. If you continue to exceed this limit, your access to the geocoding API may be blocked. The geocoding API may only be used in conjunction with a Google map. Geocoding results without displaying them on a map is prohibited. Interesting. I wonder why that is. For complete details on usage or allowed usage, consult the Maps API terms of service.
Coding API that we're talking about has at one point in time 2,500 requests a day. You can get more requests if you get a key. Now, another API that we can talk about is the Twitter API. Now, Twitter API started out as a free public API, but then Twitter realized that people were making more money off of Twitter's data than Twitter was making off of Twitter's data. And so Twitter makes it so that you have to have an account. You can only request data from their API is if you use your account key to sign that. And so there's a whole series of getting and issuing keys and then using those keys. And I'll just give you a short summary of the kind of code that it takes to build those requests up that have to be signed.
What the heck is Twitter's API? Like the data that Twitter or X now. The HTTP at the beginning of a URL or of URLs is command to the browser. Tweets are the basic atomic building blocks of things. Of all things Twitter. I don't know what I'm supposed to be looking at.
So you'll look through the Twitter documentation, and it'll say, oh, this URL to get the tweets, et cetera, et cetera. And it says do a GET request.
Oh, so that's the data, is the actual tweets? Returns the 20 most recent mentions. Tweets containing a user's @screen name for the authenticating user. Timeline returned is equivalent to the one seen when you view your mentions on Twitter. Returns a collection of the most recent tweets. Oh, the posted by the authenticating user and the users they follow? Wouldn't it be like a crud ton of data? My goodness. Returns the most recent tweets authored by the authenticating user. That had been retweeted by... Oh, that had been retweeted by others. I don't know how I would use... Like, I can kind of get why this would be stuff you need to pay for.
This URL and that URL, and maybe substitute a little bit of things here for the screen name you're looking for or how many tweets you want. And they tell you how to carefully construct these URLs. And so here's an example bit of code that talks to the Twitter.
Import URL, lib request, parse error, twirl. Oh, Twitter URL. I wonder if it's still that after it's the whole switch text thing. Import JSON. API.Twitter. 1.1 friends list. JSON. While true, print nothing. Account input. Enter Twitter account if the length of account is less than one break. I feel like that's going to be a basic one. I'll just need to remember, like, I'll be using it a lot of if it's less than one break. URL equals twirl.augment. Twitter URL, screen name, account. Okay. That's the HTML, right? Or is it XML? No, that's JSON. That's the JSON bit. Count 5. Print retrieving. URL. Connection. URL to open. Data connection to read to code. I'm kind of understanding this, weirdly. Headers. Dictionary. Connection. Get headers. Print remaining headers. X rate limit remaining. I don't know what that is. JS equals JSON dot loads. Data. Gee whiz, man. Print. This is kind of thick though. Print JSON dot dumps. JS indent equals 4. Why? Why that, huh? For you in JS. Gee whiz, bro. Users. Print you. screen name s equals u, status text, print, okay, s up to, but not including 50. Holy crud.
Now, for now, I'll ignore the security bit. That's all hidden in this TWURL, so it looks a lot like the last one. We're going to use JSON and URL lib, and we have found that this is the API name, blah, 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 list.json, getting a friend list for a particular person. And so that is the base URL that we're going to do, and we're going to ask a person for a Twitter account. If we hit enter, we're going to break out. And TWURL augment, we're going to say, give me the first 5 friends of this particular screen name, the one we just read in from input. And this TWURL, you'll see in a second, it adds a bunch of stuff in from input. And this TWURL, you'll see in a second, it adds a bunch of stuff to prove that name, the one we just read in from input. We're going to break out. And TWURL augment, we're going to say, give me the...
I'm sorry, my second screen keeps freaking out over here. Is it the page I'm on? What's going on? Chill. I'm gonna see if it does it again. Hello? Alright then.
The first 5 friends of this, and TWURL augment, we're going to say, give me the first 5 friends of this particular screen name, the one we just read in from input. And this TWURL, you'll see in a second, it adds a bunch of stuff to prove that you are who you are. It's signing that URL. So you're sending a signed URL, which is nothing more than a whole bunch of crazy characters. We'll see that in a second. We retrieve it, and this is pretty straightforward. We can just, open the URL, read it and decode it. Decode solves the UTF-8 thing, makes it all so that data is a real string and it's in Unicode internally. Now we can actually get the headers. Remember I told you earlier that URL open bypasses the headers, but it's stored them for later. And we can say, hey, give me back those headers. And that gives us back a dictionary of headers. And the headers, if you go all the way back, are a bunch of key value pairs. Key, colon, value in the headers. And in Twitter, if you read the documentation, there's this x-rate limit remaining that tells you each time it returns to the API, response to the API call that you made, it says, look, you've got 12 left. You've got 11 left. You've got 10. So you can print that out. So this prints out how many you've got left.
Oh.
Then we parse the JSON data. We're going to print it so we can debug it. This dump to string, and then printed. Indent equals 4. This is called pretty printing. And it's indenting things really nicely so that you can make more sense of it. Whereas when these things are when programs are talking to each other, they don't really make the output look particularly pretty.
Yeah.
And then if we're going to go through, we have the outer thing of users, and we're going to print out the screen name and go grab the, for each user and users, we're going to print their screen name, we're going to grab their status text and print that out. And so this is what that data looks like.
Whoa. Can we do this? Is this going to be what one of the exercises is? All remaining 14. Users, status, text. Oh, look at that's a tweet. Wow. Huh. Wait, so that's like, wait, what? Users, and then it just spits it out. Oh, so that's like a cleaner way. Okay. So that must have been what that lower bit of text, that lower bit of code did.
kind of chopped a bit. So the thing we get is an outer layer, we get users, and then we get a list. And here's the first user. Now if you look at the actual data, it's much larger than this. Here's a second user, and then we have status text, and the screen name, right? And so those are the bits that we're extracting from that. If you look, we're status text, and the screen name.
Oh, duh.
Right? And so those are the bits that we're extracting from that. If you look, we are going to grab the screen name. And so those are the bits that we're extracting from that. If you look, we are going to grab the screen name, we're going to grab the status text, and away you go. So,
yeah, that's right.
Wait,
no, that's not the bottom part. I was wrong. I thought that's what that was.
You can start with this, but you realize that once you're looking at this and you're printing this out with pretty printing, you can sort of work your way in, knowing that it's either a dictionary or a list. If it's a dictionary, you look up the key. If it's a list, you say which position it is, and then you get more dictionaries within dictionaries within dictionaries, and away you go. And so this code actually, when it runs, it prints out the screen name and then that status and the next person. So it's my first 5, in that case, my first 5 friends and their most recent status, the first 5 people. Now, let's talk a little bit about how the security works. And so you have to go to the website. You have to have a Twitter account. You can't talk to Twitter API without a Twitter account. And then you go to this website, and then you set up a key. You say, I'm going to build an application that is going to consume the Twitter API. And then you go in, you have to work through, there's documentation on how all this stuff works. You set up an API key, you set the application. So I made a key called Python on my laptop. And it gives us some values. It gives us a consumer key, a consumer.
So this is something you built.
Secret, a token key, and a token secret. And you get to regenerate these. And there's this file called hidden.py, and you edit them and copy and paste all the stuff from those pages, those 4 values, into these strings. Now, if you download my code, I don't have my keys in there. I got some from those pages, and you get to regenerate these. And there's this file called hidden.py, and you edit them and copy and paste all the stuff from those pages, those 4 values, into these strings.
Okay.
Now, if you download my code, I don't have my keys in there. I got some placeholders for this stuff. So you got to get to this web page that's on Twitter, copy these things in, and then the TWRL code will start to work.
I'm not going to worry about that for now. I feel like he's going to have us come back to that in the exercise. One of them.
Uses a technology called OAuth, which is a way to sign a URL in a way that proves that you have the key and the secret and the tokens, but and it can't be modified in the middle. So once you send this URL, they can check the key and the secret to make sure that you truly signed it without actually sending the key and the secret. It's actually kind of cool and fascinating, but we won't go into it in great detail here. And so if you look at the code,
wow. Import URL, OAuth, hidden. Secret, hidden.oauth. Consumer, OAuth, consumer. Secrets, holy smokes, bro. What the heck is all this? Okay. I don't know. Whoops.
in TWURL.
Excuse me. BOD consumer key GNG. OAuth signature method.
URL.py.
SHA-1, I don't know.
This is the code that does it. It actually pulls in an OAuth library. That hidden.py, that is that code that you've got. And it's got the consumer key, the consumer secrets. This is pulling that from hidden.py. This is a lot of stuff that's using this OAuth library. Don't worry too much about that. Eventually it produces a URL that looks like this. And what happens is this was the base URL you were told to use. Then you have count equals 2 and screen name equals Dr. Chuck. Those parts.
What? Where's that?
Are your. Eventually it produces a URL that looks like this. And what happens is this was the base URL you were told to use. Then you have count equals 2 and screen name equals Dr. Chuck. Those parts are your parameters to that web service call. And then all this OAuth stuff is produced by this OAuth code and the consumer key and the secret. What happens is the key gets sent, and the secret does not get sent, but they send this signature, which is based on the secret. And then what it does is it rechecks the signature on the far end. Signature is a long string. By regenerating the signature, because the secret's available to both you to generate the signature and to them to check the signature. So it's kind of like a hash, et cetera, et cetera. You don't have to worry about all this. These URLs get really long, and your values that you need are in, the name of the URL is in, and you call this routine. That's called augment. That takes a URL and then parameters and then augments it by adding all this OAuth stuff. And so that's why it's called augment, to augment the URL. And once you got this set up and hidden working, then you sort of just augment the URL and then hit it. Now, if you don't have the right keys or secrets, or you don't have an account on Twitter, then it's going to blow up. But if you get it set up, you will be able to talk to the Twitter API with it.
Okay. Summary. Service-oriented architecture allows an application to be broken into parts and distributed across a network. An application program interface API is a contract for interaction. Web services provide infrastructure for applications cooperating an API over a network. SOAP and REST are two styles of web services. XML and JSON are serialization formats.
So this whole web services section, we've done quite a bit of stuff, right? We've looked at how instead of reading HTML or flat text, we are creating structured data according to contracts, whether it be XML or JSON. We can retrieve and parse that information in a deterministic way. We talked about schemas that define the contracts so that you know if the data you're getting is wrong, you can know who to blame because the schema gets violated. And we've played with APIs where you're talking to someone else who's defining what the rules are and how to read their documentation. And even if they have an API key or need signed URLs, showed a little bit about how to do that.
Whew. That was a thick one today. Yeah. That is going to do it for today. Tomorrow we're going to get into, there is a Twitter exercise. I'm just curious how this is going to go. I have never at all dealt with digging into the API of a thing. But that is going to do it for me today. Thank you guys so much for watching. If you enjoy this sort of thing, please leave a like and comment down below. Comment down below if you have a prayer request. I'd love to know how I can be praying for you guys. But then subscribe as well if you like. No pressure. But if you want to, go right ahead. Love to have you here. Have you more, I want to say permanent, but have you more part of the the community. But for right now, and not just for right now, I did this before, but love God, love people, and I'll see you guys soon.